Hello, this is Jason Harrington, and I want to do some examples in Excel to show you how to answer all these questions as fast and as efficient as possible. And you can use Excel on the test, and particularly the next lab, I'm just going to have you use Excel for most of it because it's very easy to use. So this is the example I want to use, the first one. This is going to be a very simple example. I'm going to have y prime is equal to y minus t squared plus 1. And I'm also going to start with, we know that t is going to be between less than or equal to, t is between 0 and 1, or 0 and 2 in this case. I'll make it go a little bit longer. And our initial point is that y sub 0 is equal to 0.5. So this is the initial setup, and I want to approximate what is y sub 2 going to be using Euler's method. Alright, now of course this doesn't fit, so you can always highlight all the cells and click down Format Cells, and then you can say things like alignment and merge the cells together so it all fits. You don't really have to get that fancy, but it's good to make sure it's readable. So this is what I'm going to do is I'm going to set up the table. I'm going to have t, and in my t I start with 0. Now I also need a step size here, and in this case, if I'm given that n is equal to 10, the number of steps, then the question is, what should my h be? So my h, and this is true for pretty much any h that you had to find, like even with the trapezoid method or Simpson's rules, it's going to be right here. I'm going to look at the stop minus start. So that's going to be stop minus start. And then I want to divide that through by the number of steps, which is 10. And to put a little equal signs there to say that it's 0.2. And to make this a little bit lined up better, I'm going to put that alignment to the left. Okay, and also I'll put the t to the right as well so I can put it all together. Now the next step is going to equal to the previous step plus this 0.2. Now I want to lock it down. I don't want that to move. See, if I just hit enter and I drag it down, I'm going to have a bunch of errors. Or not really errors, it's going to not give me what I want. But see, if I just drag it down, it just gives me 0.2, because if I click on this cell, for example, it starts to reference over here. So in order to lock it down, what I want to do is I'll come over here to K3 and I'll put a $ to the left of K, and what that does is it locks down the kth column. So now that the kth column is locked down, I'll also highlight the 3, or sorry, I'll put a little ampersand, or sorry, a $ in front of the, where is it at? In front of the 3 so that it locks down the row. So now the column in the row is now locked at K3. And when I drag this one down now, you'll see I get exactly what I want. I'll go 0.2 and the next one will be 0.4, and I want to drag it all the way down to just 1. And then now I want to go down to 2, and you can see how many steps it takes. Again, you can line this one up however you want. Sometimes I like to play with it to see if what looks the best. Now my approximation W, so this is my approximation, and I'll usually use like EM for Euler's method. And again, that's a little bit out of line, so I'll widen this up a little bit just so I'll be able to see the column. And we already know from this statement here that 0 starts at 0.5. So I put in 0.5 as my start, and I hit enter. Now what I'm going to do is I'm going to just do Euler's method. Now Euler's method says take the previous point plus h. Now remember, we already have this h, and again the h is the same for all of them, so I'm going to go ahead and lock that down so it doesn't change. I mean, granted, I am doing a little bit of overkill for putting a $ in front of both, but better safe than sorry. And then I have to put in the function f. So I'm going to put times. Now the function comes from right here. So it's going to be y minus t squared plus 1. So I'm going to do the previous approximation, y. Then I'm going to do minus t squared, which is this guy. And usually I just multiply it by itself again. I mean, there are square commands inside of Excel, but I'm an old school programmer. That's usually what I like to do. Plus 1. And I hit enter. And I get 0.8. And you can see that when I drag it down, this is what I get. The last one is 4.865845. Now, I actually compute the actual solution as well. Now, sometimes the actual solution isn't given, so you don't really know unless you use that error formula that I gave you. But if you happen to know the actual function, which I'm going to call y, and again, I'll make this column go to the right just like the other two columns. I will call this one y is the actual amount, and I know it's 0.5 because it all starts at the same point. Now over here I'm going to write down what the y value is, and again I'll move this over so we can actually see it a little bit better. Whoops. I'll move this one over. So this one, my y is going to be equal to t plus 1 squared minus 0.5 e to the t. Again, it doesn't quite fit as nicely as the actual function, but that's the actual solution. Now, the thing is about the actual is that typically that's not really given to you. And if it is given to you, you can work with it. But, and I'm going to say this as a word of caution, you don't have to solve the differential equations. I know a lot of you have had differential equations before, and some people actually on the test waste a lot of time trying to derive all these equations. You don't have to. If I don't give it to you, don't worry about it. And then if I give it to you, just use it. So this is not a differential equations class. We're just going to figure out how to approximate these solutions and not really worry about where the actual solutions come from. Now, for this one, I'm going to say, and again, this is just in terms of t. So I'm going to have t, which is this value here, plus 1, I guess I'll use a squared here, see if that works, minus 0.5 times the exponent of t. And I hit enter. And you can see that the first step is actually pretty close. And the squared actually does work. I'm one of these people that actually is afraid to use the square because there was a time when Excel actually forbid it for some reason or put it in a special command. So I've always been weary of using it. So now you have the approximation from Euler's method, and then you have the actual solution. Now what you can do now is find the actual error. Actual error. Put a little bit of space for that so we can see it. Now the actual error is given by the absolute value of w minus y at each step. A lot of people have forgotten the absolute values, but you need to figure out, you definitely need the absolute values because you're looking for the worst case scenario here. So we're going to do the absolute value of w minus y. Now on the first step, you should always get 0 because every one of them has the same starting point. Now if I drag it down, you can see what happens to the error. You can see that the error is actually growing quite a bit. And what else is neat about this is, let's suppose I want it to do 0.1 steps. Let's suppose I want it to do 20 steps. You can see now the whole thing changes, and all I got to do is just drag this down and do sort of double the points to see what happens. Oh, went a little too far. I can delete this last row, stop at 2. So now if my n was equal to 20, we can see exactly how that would change and exactly how the error bounds would change and how close would it be. You'll notice that when h is smaller, most of the time, not all the time, but most of the time when the h is smaller, you'll see that the approximation gets better. Now hopefully you learn how to do this in Excel. Euler's method is the easiest one to do first, but we will be using it for more complicated algorithms later on. And of course you can always clean this up and make this a little bit more interesting. Sometimes I like to just format the cells a little bit differently, put different borders around things, make it all cute and fancy. Let me put this down here first. But the main point is, once you have it done in Excel, then when it asks you multiple questions like what happens if you change the n, how does that affect the outcome, you can actually do that very quickly. Type it in Excel, hit enter, bam, the whole thing changes for you. I hope this helps.